Comb. Okay, so we're going to talk about this particular questions. Water drain from a conic tank at a rate of 2 meter cube per second, and the tank is 16-meter height, 16-meter height. So we're gonna use this problem. So we're gonna put it on the thing. Import done. Okay, so this is a question that we're gonna be dealing with. Water drain from the conic tank at a rate of 2 meter cube per second. The tank is 16-meter height and its top radius is 4 meter. How fast does the water level fall when the water level is 12 feet height? With going over this question, it's going to help you with some type of geometric one. And this one's the hardest one. Okay. So we have a comb, and let's draw the inverted comb. So I'm going to use my thing. It's going to draw an inverted comb. Oops, that's not a comb. It's going to have a comb. We're going to be realistic. There's water in there. And this is water. Okay. And on top of the things, let's extract information. The tank is 16-meter height. So from here to here is 16. So from here to here, 16. And for radius is 4. So from here to here is a 4. And from here to here is 16. Any questions so far? Now, how fast does water falling when the water something? So let's figure out what is 2 meter cube per second mean. What do you think that mean in terms of calculus? Ethan?
Yeah.
Why do you know it's dV dt?
Because it's got the meters cube, which means that we get volume.
Yep. And but the problem is, what do I have a mistake here? If I just write on dV dt equal to 2 meter cube per second, there's some mistake I purposely make. What kind of mistake you think I make? Yes. Why is negative? Right. So the key word is draining. Right. dV dt. Right. And that's it. And what they asking though? What do they want? What do they want here? In terms of calculus, not just only what they want. I mean, it's really obvious what they want. But in terms of calculus, what do they want? dH dt. Good job. N is equal to unknown, right? And there is a condition. A condition is what? H is equal to 12. Does that make sense? So that's a straight line conditions, and we're it down. The problem is, okay, so now what will be the relationship I'll be using here? Caroline's looking up. Guess what? You had to memorize it on Wednesday? But that's good. You have a place to look it up. One-third of cylinder? Good. One-third of cylinder. What is one-third of cylinder? What is cylinder?
Oh, it's pi r squared times h.
Pi r squared times h. Good job. Okay. Now, I want you to think about foresee this problem. The foresee the problem is they want a dH dt, but if I take a derivative of current status, I am not gonna have enough information because I will have dr dt and dH dt, but you have two things that you're looking for, and that creates a problem. Okay, so you will have a product rule, and then you have some type of r squared h. So there's the the product rule issue that drdt and dhdt all at the same time, and you only have one of them that you're looking for, but you have dvdt is giving, so you're missing drdt, so therefore you cannot do it. So that means that calls for the second relationship. So what is second relationship here? Can somebody tell me what second relationship happened here? What is it? What kind of triangle? They're right triangle, but there's more specific kind of right triangle in this case. You can tell when you turn your head sideways. No, not necessarily 30, 60, 90 here. Yes. Isosceles? No. It's not isosceles. This is right triangle. What kind of relationship are they? It's on the first day I give you the relationship. Similar, thank you. Similar relationship. Okay, in similar relationship, you can use that as the R over H. R and H is gonna be a relationship. But the thing is, there was a constant in this comb. What kind of constant is that? The radius and the height, right? That's not gonna change. Well, the radius of the height of the comb is not gonna change. Yeah, the water is changing, but the radius of height is always the same. So if you're halfway at the I8 height, then your radius is probably gonna be half of that. So it's a proportional. So this is a proportional that you need. So then you will have a 4 over 16. Does that make sense? And you have R over H is equal to 1 over 4. But the thing is, what am I solving for? Am I solving for R or am I solving for H? And how is each one different? What are we looking for? That's the question you should ask. We're looking for dH dt. So what am I solving for? Why R?
Because if you're solving for dH dt, then whenever you find the derivative of the h in your volume equation, it's already going to go to dH dt. And if that's what you're solving for, then all you needed to find is dr over dt.
Yeah, but we don't have dr dt. The problem is we don't have dr dt, so we want to solve everything to h. Why? Because if I solve everything h, I can substitute, change everything in term to h. Then I got dH dt, which is the unknown. Does that make sense? So then you're gonna go back, you're gonna say, okay, well, that's gonna be v equal to 1/3 pi r squared h. Now with that relationship is 1/3 pi, and we're gonna use a color code so that way you can tell the difference. The r is gonna be h over 4 square h. Why h over 4 square? Because 1 over 4 h is the same thing as h over 4. And that's equal to the sorry, that was horrible. Square and then times h. So I basically just substitute the r. And then I'm gonna evaluate it, I'm gonna simplify it. That means the top square and bottom square. So we get h squared over 16 times h. So that means 1 over 3 and 1 over 16 is 1 over 48 pi h to the third, v. Now, I'm in the game. Why? Because I have dH dt is unknown, dv dt is giving. All I do is take a derivative with respect to time, and voila, you are there. So d to the dt here, I'm going to get dv dt is equal to 1 over 16 because I dropped the 3 down. 3 over 48 is 1 over 16. And this is pi h squared dH dt. dv dt is equal to what? Well, 1 over 16. According to the question, they says at 12-meter height. Right? So can I plug in 12? And the dHdt unknown. And we also can plug in dVdt, so it's going to be 1 over 16 pi times 144 times dHdt. Nice thing is this 144 and 16, they are multiple of each other. So 144 divided by 16 is what?
Wait, what?
What's 144 divided by 16? No, that's okay. 144 divided by 16, that's not going to be 3, no. Would it? Nicholas? Good job, 9. Because 16 times 10 is equal to 160. If you subtract 16, it's 144, so it's 9. So negative 2 over 9 pi is equal to dH dt. Got it? No problem.
Where did the 1 over 4, for the R over H, like, where did the 1 over 4 come from? Like, I think he's, like, where did,
I just reduced 4 over 16.
oh, okay, thank you. I thought, okay, thank you.
Yeah, that's okay. That's just simplifying, so
Okay, I wasn't sure if it was from, like, a different, like, part of it.
nope.
That makes a lot more sense.
Any other questions? So what I'm gonna do is I'm gonna somebody have a cell phone. You have a cell phone, you have a flashlight. I need a help. Right. So what I'm gonna do is I'm gonna introduce you a new question. I'm gonna read. We're gonna read together. And this is the questions. A man is 6 feet tall, walking at a rate of 5 feet per second, away from the light that is 15 feet above the ground. Right? So what we're gonna do is we're gonna go in and we're gonna think about those things. A man is 6 feet tall, walking at a rate of 5 feet per second, away from the light that is 15 feet above the ground. See figure. We didn't draw the figure. You had to visualize that. A, when he is 10 feet from the base of the light, what rate is the tip of the shadow is moving? When he is 10 feet from the base of the light, what rate is the length of the shadow is changing? So now we gotta talk about this question. Katie, you have a cell phone, right? Okay, yeah, and then you can turn on the flashlight, right? And I'm gonna record the section on my phone. So somebody gonna, I needed 2 assistants. Um, why is not recording? Okay, so first of all, I need help. One is a flashlight and one is a recorder. So Kevin, you want to be a recorder? Sure. So record situation. Katie is gonna be the light source. Katie, come here. Katie is gonna sit here. Okay. So you're gonna cast the light this way. You're gonna pretend like this lamp. Oh man, not dark enough. What's your place? Is your light strong enough? the light. Okay, so the light is going to be right here. So you're gonna hold it. Yeah, you can record. So basically, is this man is walking away, right? Think about the lamp, and then that you guys can come here too, by the way.
Right in the middle of this, I have no idea how we'll get it turned on.
Oh, well, we're gonna try. So this one is walking away, right? So you see the shadow is growing, right? You see the shadow is growing. Do you see that? If I go back, it's gonna go the other way. But if I'm going from here, this shadow is gonna grow, grow, grow. So now let's go back and look at the questions. The question says, when he is 10 feet from the base, the light at which the tip of the shadow is moving. And then the second question is, so when he's 10 feet away from the light, what rate is the length of shadow changing? What the hell they asking? Similar triangle, but is any difference between A and B? A is asking tip of the shadows moving. B is asking what rate is the length of the shadow changing? Are they any different? Or are they the same?
I think they're the same.
You think they're the same?
Yeah.
You can record people. You can record questions. You can use any camera of anyone. So we're gonna be a realistic. Okay, so what do you guys think? Are they different? The tip of shadow is moving versus you're creeping me out. Versus the shadow length of its shadow is changing.
The tip is probably moving faster.
The tip is moving faster. Anybody else?
Is the tip the one that's not changing size?
The tip is not changing size. I have no idea what that means. But okay. Katie, what do you think? What do you think?
They're probably gonna be different values. I don't know which one would change faster.
Kevin, what do you think? You're gonna have to film yourself.
I was gonna say it'd be a really awkward angle, but I think the tip of the I think the tip of the shadow probably moves faster, just as you see like the relation as it's going farther back, it changes quite drastically.
Okay. Caroline,
You're absolutely much
I agree with them.
you agree with that? You cannot just agree with that. You gotta be. This is what I believe. I don't give a shit about what do you believe. You think tip is gonna move faster?
It's rubber square, that's why it's
Okay. Anybody else? Ethan?
Probably just gonna go with what everybody else is saying. Sounds like the consensus is pretty clear.
Okay. Sarah? Both Sarah? Hi, Sarah.
Yeah, I just said probably gonna go back.
The tip is faster. Okay. So let's come back. I'm gonna go answer back to the question. What did you say?
Thank God they don't have this. Like during the test, I'm trying to visualize this.
Well, no, that you might be. It's a might be easier than you think. A lot of times, like people try to overcomplicate things, but it's not. It's a things like a lot of times people don't know what is things relate to each other. And I really want to use this classical problem. They don't test this on AP exam. They used to. 1980s. They test this question a lot. And student just can memorize it. But as I don't want a student memorize, I want a student actually understand what is going on because this is very, very important. So first let's draw a picture, right? This is a picture that we're gonna be having. So So this is the lamp, and this is the man. I don't know how to draw a stick figure. I think that's it. It's gonna cast the shadow. That's perfect. Okay. Now this one is a 15 feet. Okay, 15 feet. He's 6 feet tall. Anybody 6 feet tall here? Ethan, are you 6 feet? Or Kevin, you're 6 feet? So Kevin's walking away from the light. Okay, Kevin's walking away from the light. So a man is 6 feet tall, walking at a rate of 5 feet per second, away from the light that's 15 feet above the ground. When he is 10 feet from the base of the light, at what rate is the tip of shadows moving? And when he's 10 feet from base of light, what rate is length of the shadows moving? So, so we say you think that, so what do you think, guys think? What I mean by tip of shadow, what's the difference? You say tip of shadow is going to be greater than the shadow is changing? Is that what you guys concluded? Yeah. Okay. Okay, now let's assign some variables first. Let's say we have this side is the x. Why I build that? I built a similar triangle. I'm gonna say this is y. So my first question is this. They say is walking at a rate of 5 feet per second away from the light. So is that a dy dt or dx dt? So what is 5 feet? So first question is what is 5 feet per second? Is that dx dt or dy dt?
Wait, where's the X? Is the X this side or is it the bottom? I don't know.
I don't know. It's right here. He's walking away from the light. Is that dy dt or dx dt?
Couldn't it be like
Could it be
both, but they're just like inverse? Like dy dt would be like positive 5, and dx dt would be like negative 5.
Can it be both? Okay. I think I see that reasoning. Okay. What is 5 feet per second? So he says could be positive and negative. Anybody else have different thinking? Katie is thinking what?
Well, if the Y is also horizontal, then would it be, then it could be dy dt, because that's what's changing, really, if he's moving farther and farther away from the little, like, lighting thing.
Okay, so she says dy dt. Anybody else have taken differently? Kevin?
I said dy dt because it's in relation to the lamp and the person, not the shadow.
Sarah, what do you think? Sarah Zhang? dy dt because everybody says so? She's honest. She's like, yeah, I'm excited he didn't ask me first. If he asked me first, I won't know what is it. Dashing, what do you think?
I feel like it's dy dt because it's a moving away. The lamp is the rate of moving away.
Anybody think it's dx dt?
I thought it was dxdt, but I don't even know because those variables, like, what is, like, why did you label that y? What is labeled y here?
Y is right here, and this is x right here.
Like he's walking towards X. Like if he's moving away from the Y, the light.
So you still think it's dx dt?
See, I don't know because like you'd also have to include the Y. I feel. Well, I don't know.
Caroline, what do you think? Okay, so we have two people think dx dt. We have two people think dy dt. We have one people can think it's positive or negative. Sarah Z, what do you think? Whatever your answer is, what do you think? That's good that you guys all believe in something, because you should believe in something and then you should modify after we correct it. But we should think about what we're thinking.
Would y be 5 feet per second to the right, and then the x would be, do they tell us like the total length was like, I don't remember, they didn't tell us the total length. Well, then what would that be, -5 seconds? I don't know, because he's getting closer and closer to like the edge, but I don't know.
Okay. Sydney, what do you think? You think it's dy dt? Dev? You can make up your mind? God damn it, you gotta be like, this is my shit.
God,
I
don't know.
You cannot curse the god and then say you don't know. If you're gonna sacrifice that, at least you have to know, like, you have to know something, right? Okay, so it is dy dt. Because the y is changing.
The x isn't changing?
Huh?
The x isn't changing?
We don't know yet. So what we're gonna do is we're gonna think about those relationships. We're gonna say, okay, well, what would be a relationship I'm forming? So the relationship is using similar triangle. And remember, the similar triangle is basically the ratio of small triangle compared to ratio of big triangle. In this case, it would be 6 over x is equal to 15 over what? No. What? No. 10 is changing. X plus y, good.
I know we got like side from the triangle.
So this is x plus y, right? So 15 is bigger, the big triangles. So it'll be x plus y. But
Oh, it's the mini triangle. Okay, never mind. Okay, I see the triangle.
small triangle, 6 over x over big x. So you're gonna multiply this, right? And then that's gonna be 6x plus 6y is equal to what? 15x. Okay. So 6y is equal to 9x. 6 dy dt equal to 9 dx dt. Are we okay? We just take it due to respect to time. And then 6 dy dt is equal to 9 times dx dt, which is, I think is 5. No. At walking away 5 feet per second. And dy dt is equal to 45 over 6, which is equal to what? 15 over... Did I do something wrong? Oh, this one is 6y.
Isn't dy dt 5 and dx dt what we're
Oh,
solving?
dy dt is 5, my bad. So thank you. So it'd be 6y, so 6 dy dt is equal to 9 times dx dt, and the 6 times 5 is equal to 9 dx dt, and then dx dt is equal to 30 over 9, which is 10 over 3. Okay, so here's my question. dx dt is a or b? What is dx dt? Are they a or b?
What's the question again?
It's the length.
Are they answer for a or answer for b? I find the dx dt. Are they answer for a or they answer for b?
Is it B?
Probably.
Or which one's? I know it's A.
Yeah, I think it's A. Isn't B like dl dt?
And B like dx. plus dy dt.
What is it?
For b? Or, yeah.
What time we get off here? 9:10. Okay, so I'm gonna give it to you. Dy dt is the answer for B. Because that's how fast the shadow is growing. Now, far as 10 feet away from the base of light, what tip of shadow is going to be x plus y equal to z. So z is represents the tip of the shadow because it's including here to here. So in here, dz dt is equal to dx dt plus dy dt, right? So dx dt is what? 5 plus dy dt is 10 over 3. So it'll be 25 over 3. So dz dt is the tip.
Where do we get
And dx over dt is 10 over 3, right?
Yeah. So would you have to solve B before you solve A in this like case?
Well, you can solve either one, depending on how you assign a variable. Either way is fine. This is the way I assigned it. I meant to let student think about it. So yeah.